Hello students, how are you? Today will be formally starting our AFM paper syllabus. Our first topic will be investment appraisal, which makes roughly 60% of your syllabus. Okay, so very important topic. First of all, I'll be just briefing how we will proceed this topic. I'll be giving you the class notes. Okay, this thing I'll be referring to you in the first few lectures. Okay, class notes, and those class notes are prepared from Kaplan study text. You will find out they will be Kaplan study text. So if you are following the class study notes, their chapter numbering will be different. Okay, their chapter numbering will not be the same. Okay, not be same as of book. So first of all, make this thing clear. So if you don't want to follow the Kaplan study, sorry, my class notes, then you can just follow the Kaplan study text because both notes are same. I have just, I have those notes and those notes are summarized form of the Kaplan study text. Okay. So like for example, in total, we have 16 chapters in your book in Kaplan study text, but in your in your smart study platform, you have around 20 plus chapters because those 20 plus chapters are made from those 16 chapters. So numbering will be a bit changed. Second point, as I told you in the introductory lecture, that first we will be doing our numerical portion. Okay. So here I'm giving you that the numerical portion because uh, 30 almost 25 to 30% of your paper will be from investment appraisal calculation. So from this, you can understand that how much important are these calculation or numerical portion of investment appraisal. First of all, I'll jot down what are the actually topics of numerical in investment appraisal. The first one is the basic techniques of investment appraisal. The first topic is this. The second topic would be when you will be completing the techniques. In the book, second topic is foreign subsidiary or foreign investment appraisal. But I'm not following that order. Okay. I'll be following my own order because I'll be basically moving from uh, easier areas to difficult ones. Study text is basically from its own point of view, but I'll be moving from easier topics to the difficult ones. So then I'll be moving towards the topic very important, and that is WACC, weighted average cost of capital. Okay. Then after doing the WACC topic, I'll be moving towards another topic which is called adjusted present value topic. Then after doing that, I'll be moving towards another numerical portion topic that is option pricing model. And after doing that, I'll be moving towards foreign investment appraisal. Okay. So now you can understand that my first aim is that how domestic investment appraisal is made, how you will be able to just have a competence over domestic investment appraisal. Then we will move towards foreign investment appraisal. So this will be my order. And the last, the risk and uncertainty in investment appraisal. So these will be the topics which I will follow in the order. Now let us move towards the first topic, and that is the investment appraisal techniques. You know, one of the prerequisite of financial management is the knowledge of business mathematics. So before moving to the detailed knowledge of investment appraisal technique, I would like to just give you the knowledge of the business mathematics, which is required in this paper, okay, which is required in this paper, because in lot of calculation, you have to apply your basic business mathematics knowledge, okay. For that purpose, so my first lecture will be definitely based on the business mathematics issues. Let me change the color of the, okay, make this one. Let's have this one. So first of all, if we start with, you know about it, future values. Future values, or it is also called a compounding. We can say that compounding is a process from which we can measure the future values of any amount. Its formula is very simple. S equals 1 plus R raised to the power n into P. S is the future value. R is the rate at which you are expecting that value will increase. N is the number of periods. And P is the amount now. So for example, if 1 unit costs $10 now, and in your country inflation rate is 10%, what is the per unit cost after 5 years? In other words, I want to calculate its future value. Okay, so what I will do, S equals 1 plus, what is the value of R? It is 0.1. N is 5. And what is the amount now? $10. Let's say I am just making assumption 15. So this is the future value. Okay, so this is the concept of future values. And one thing more that I think you heard about it, the difference between simple interest and compound interest. Simple interest is the method in which interest payments are basically made on the principal amount. This means that each year interest payment will remain constant. But in compounding or in compound interest, interest payments are not based on the principal, they are based on the sum value, means they are based on the future values. So each year's interest payments are not same. For example, you have $100 at the rate of 10 each, 10%. So if I follow the simple interest concept, investment will remain 100 in each year, and interest will remain 10, 10, 10. But in case of compound interest, if you have 100 investment and 10% interest, in the first year, 100, you will earn the interest 10. In the next year, interest will be applicable on the sum, 110. In the next year, it is applicable on 121. So this will be 12.1. So how you see here, you see that interest is increasing in each year. Normally, the if you see, if you are employee somewhere, your gratuity funds, your provident funds, they are compounded. They are compounded so that your value will be multiplied, and that value will be available to you when you retire from your employment. That's not the topic here, but that's I'm giving you the example where compounding is. Banks also use the compounding in the on the fixed deposit schemes, that if you deposit with us for the first, let's say for the 10 years, we will make your amount double, or we will make your amount 3 times. How they are basically offering that amount? Insurance companies, they also offer compound interest. Okay. Next topic is more relevant, and that is the discounting. Discounting. Discounting means find out the present value of future amount. So if you want to check out what is the present value of the price after 5 years, let's say after 5 years, price per unit would be 10. What is the present value of that 10 rupees or $10 right now? This is what we call discounting. Formula is very simple. 1 divided by 1 plus r raised to the power n into amount. You can also 1 plus r raised to the power minus n into amount. Now, because majority of your calculations are based on discounting, so I'll follow the discounting here. Next is annuities. What are annuities? Same cash flows for definite time period. If you have similar cash flows, constant cash flows for definite time period, these are called annuities. 1, 2, 3, 4. Each year you have 100 cash flow, 100 cash flow. So we can say that annuity of 100 for 4 years. So now how you will find out the present value of annuity? Very simple. Just take the annuity and multiply it with annuity factor. Now annuity factor table is given to you in exam. That will be available to you in the exam. Don't need to worry about the formula of the annuity. It will be given to you in your exam. Okay. Now let's solve some examples. Let's have a better understanding of it. Examples. First of all, normal annuities. Normal annuities means that annuity starts from year one. For example, 1, 2, 3, 4, 5. In year one, you have a cash flow of 200, 200, 200, 300, 400. So here you see for the first 3 years, you have the cash flows, which is same. So 200 starts from year one. This is normal annuity concept. So how you will find out the present value here? Assume 10% discount rate here. So now tell me, for the first 3 years, we have annuity. So I can find out the first 3 years present value. How? Annuity multiplied by annuity factor. Year 4 and year 4 and 5, they are not in annuity, they are simple cash flows. So cash flows must be multiplied with discount factor of year 4. Cash flow must be multiplied with discount factor. Here we have an annuity of 3 years, so I will be multiplying it with annuity of 3 years. Discount factor of year 4, discount factor of year 5. So if you see the table, 200 into 10% 3 years annuity would be 2.487. Just look at the table, you will be finding it 10%, 3 years annuity would be 2.487. Cash flow 300 into, go to discount factor table and take the 4th year discount factor, it is 0.68. I have a lot of basically, I have basically memorized some of the values. So that is why I am just writing it over. You can just check your answer from your table as well. Okay. Next is cash flow 400 into discount factor of year 5. So this is 498 plus 204 plus 240. This is 950. Okay. Another example. 1, 2, 3, 4, 5. In the first year, we have a cash flow 200, 300, 400, 400, 400. Now here you see annuity starts from third year. Annuity starts from third year. Okay. So this is called delayed annuity. This is called delayed annuity. And this is the key feature of your questions. Delayed annuity and delayed perpetuity is the key feature of your questions. So you should know how to solve the present value of delayed annuity concept. First of all, how you will find out the present value of delayed annuity? Very simple. Take the annuity, multiply it with annuity factor, and multiply it with the previous year discount factor. Because here annuity starts from year 3. So when you multiplied the annuity with annuity factor, this will be the present value in year 3. Now you have to basically move it to year 0 because you have to find its present value. So you have to multiply it with the previous year's discount factor. Okay, always remember. Let's say, for example, if you see that annuity starts from year 5, take the present value of annuity and multiply it with the discount factor of year 4. That's it. Okay. So always remember that once you are into delayed annuity, multiply, don't forget to multiply it with the previous year discount factor. So now 200, assuming 10% discount rate, 200 into 0.91, 300 into year 2 discount rate 0.826 plus, now we have annuity. 400 annuity is there into, I'll multiply with annuity factor of 3 years. 400 into 2.487. Then I will multiply it with the previous year discount rate 0.826. This is the present value of annuity. Then I will multiply it with the previous year discount factor. So the total value is now, the present value is around, this one is 822, this one is 248, this one is 182. Just make them add and you will have the answer. Next example. Now you see that how many examples I am just solving. Just for the sake of a better understanding, we will focus on as much as possible, as many examples. 1, 2, 3, 4 onwards we have annuity from year 4 to year 10. 100, 120, 150, 200. Now 10% assumed the discount rate. So here we can say that annuity of 200 starts from year 4 till year 10. How many years are there? 7 years. So 7 years annuity factor will be applied. 100 first year is not a annuity. This is basically discount factor 0.91, 120, 0.826, then 150, 150 multiplied by 0.75. So from year 4, we have an annuity of 200. So what I will be doing, 200 into annuity factor of 7 years into discount factor of previous year. From which year annuity starts? Annuity starts from year 4. So I'll be multiplying it with the discount factor of year 3. So 200 into 7 years discount factor is 4.868 into annuity starts from year 4. I'll be multiplying it with the third year discount rate. This is 0.75. 1, 2, 3, 4. Just add them and you will have a present value. So this is the concept of annuity and delayed annuity. Now let us move towards other concept, and that is perpetuity. Perpetuity. Perpetuity is, you can say, a constant or similar cash flows for indefinite time period. And how you find out the present value of perpetuity? Present value of perpetuity is equals to annual cash flows divided by discount rate. Let's have example first. We have perpetuity of $100 from year 1. Discount rate is 10%. So what is the present value? 100 divided by 0.1. This is 1000. Another example. We have a perpetuity of 100, and that 100 starts from year 3. Assuming discount rate of 10%, you have just understood the concept of delayed annuity. So this is the concept of delayed perpetuity. What is delayed perpetuity? Simple is that if perpetuity does not start from year 1, it is delayed perpetuity. And rule is very simple. Take the present value of perpetuity and multiply it with the previous year discount factor. Same rule. Whenever you have a delayed concept, don't forget to multiply it with previous year's discount rate. So here we have 100 annuity divided by 0.1, and perpetuity starts from year 3. So I'll multiply it with the second year discount factor, and that is 0.826. So this is 826, the total value. Next example, example 3. In this previous example, I have assumed that there is no growth in perpetuity. Let's say if there is a growth in perpetuity. If you see a growth in perpetuity, then let's say at year 0 right now, we have a cash flow of 100. Okay, we have a cash flow of 100. And from year 1, we are expecting that 3% increase in cash flows. Discount rate is 10%. We have to find out the present value. So present value of perpetuity would be, formula would be here, D naught or 1 plus G divided by KE minus G. I am assuming D naught the cash flow now. Okay, G is the growth and KE is the discount rate. So current cash flow is 100. Growth rate is 0.03 divided by discount rate minus 0.03. This is your answer. Now let's further elaborate this concept. Another example. One, two, three. We have 100, 200, and we say that from year 3, perpetuity starts at year 2 levels with annual growth rate of 2%. D naught means that the growth is based on the existing cash flow. Here, 200 is the growth point. Okay, perpetuity will be there at a level of year 2. So D naught would be 200 here. I am just solving year 3rd onwards. What is the cash flow? 200 perpetuity into growth rate of 0.2 divided by 0.1 minus 0.02. Now, this is the concept of delayed perpetuity. I think now this is useful for you guys. You are basically used to it. Multiply it with second year discount factor. Another example. One, two, three. There are no cash flows and your perpetuity starts from year 3 at an amount of 100. With onwards, there will be growth of 2%. Okay, so now here, let's remember one thing. D naught into 1 plus G is basically D1. This is the cash flow of next year. So in this example, you see that we have not been provided with the cash flows right now or year 1 or year 2 cash flows. So simply we have D1 directly. Okay, so we have been given D1. So now D1 is basically D naught into 1 plus G. How you will find out present value of perpetuity now? D1 divided by KE minus G into previous year discount factor. Why? Because you see that this is delayed perpetuity. What is D1? D1 is 100, discount factor 0.1, 0.02 into second year discount factor. Okay. So this is how we are just making the difference between different types of perpetuities. This formula is applicable where you are not given with the D naught, you are directly given with the D1 application. Okay. So basically, this is the problem, the whole of the business mathematics, which will be applicable in your syllabus.